All right, ladies and gentlemen, so here we are. We're going to go ahead and deal with kites today. So our objective for today is students will be able to use the properties of kites to find missing measurements. So one of the things we do need to make note of is that the diagonals are perpendicular. Again, that's the symbol for perpendicular. We need to keep that in mind so we don't forget what that symbol is. Another property is that one pair of opposite angles is congruent. We're going to be making this a little bit longer because this has to do with the longer diagonal bisects the angles. So we have two diagonals here. We have one going from G to J and the other one from F to H. This longer diagonal from F to H is going to be obviously longer than the one going across from G to J. But it also does one other thing. The longer diagonal bisects the angles and bisects the shorter diagonal. And we're going to draw those out in a little bit. So let's go ahead and talk diagonals. So first off, we have one diagonal going across from G to J. So from G, it's going to go across to J. Notice one side of the angle is a little bigger than the other one. So it's not this one that actually bisects the other. We have our longer diagonal going from F all the way to H. And I do that lightly so that way I can fix it if I need to. So then I have F to H. And notice right here, obviously one side is longer than the other one. So this is not the one that's bisected. The one that's being bisected is the shorter one. So G and J has been bisected. So we do have a point happening there, but I'm not going to name it yet because I want to make sure we focus on this right here where the diagonals are perpendicular, which means that there's a right angle right there. Now we can put our point. We're going to put a point here, and we're going to call it point, we'll just call it P. So we do have the two diagonals. GJ is perpendicular to FH, or FH is perpendicular to GJ. So we're going to go ahead and write that down. FH is perpendicular to GJ. Make sure you continue to remember that this symbol means perpendicular. All right. We also have angles being bisected. So H is bisected into two congruent parts. So we're going to go ahead and make a note of that. And then angle F is also being bisected into two congruent parts. So we're going to make a note right here. Angle F and angle H are bisected. My goodness. Bisected. What is that? Bisected by FH. So now I have two sets of bisected angles, angle F and angle H. And that's going to come into play once we get to dealing with the tinier triangles that are in there. But for right now, we're going to go ahead and just find some missing angles here. Let's go and look at the missing angles. This is going to be our target. We have 54 and 90. Well, a kite is a quadrilateral. We're going to make a note of that because this is part of our givens. This is a quadrilateral. And I guess we should name these points. Let's go ahead and name them A, B, C, D. That way we have some references for our angles. Well, how many degrees in a quadrilateral? Well, I know there's 4 sides, so if you remember this trusty little formula, you're going to be able to figure out how many degrees in a quadrilateral. Just in case you forget, this guy is always going to help. So n is the number of sides. We do have 4 times 180, so 2 times 180 is 360. And that's something that everybody eventually will memorize, that any quadrilateral is 360 degrees. So we know that angle A plus angle B plus angle C plus angle D is equal to 360. Okay, we are missing 1 and 2. Well, what do we know about angle 1 and 2? Well, we know that these two are congruent because of this guy right here, this property. This property here tells us one pair of opposite angles is congruent. Well, 1 and 2 are congruent. So I can already tell 1 and 2 are the same. So if I label this X, then this one also has to be X. So our unknown is the measure of angle X. Our equation is this guy right here that we just wrote down. Angle A is 54 plus B is X plus C is 90 plus D is also X. We're going to go ahead and combine like terms and go from there. See you in a bit. And looky there. So we follow the process, we make sure we combine like terms, and we end up with X is equal to 108. That means each X, which is angle 1 and angle 2, is 108 degrees. So if I have 108 here, 108 here, and then we add them all together, we should get 360. You can double check your math. That would be our double check. Moving on to the next one. We're going to use our properties. So our given is that we do have two angles that are congruent, and they're the opposite angles. They're a pair of opposite angles. So does this look like 91 degrees? I don't think so. That looks like an obtuse angle. And it's going to be a lot larger than 91. And I know, well, 91 is obtuse also. But look at this guy. Angle V is a lot bigger. So that means angle W and angle U are the congruent ones. So that means this guy over here is congruent to this guy. So angle U is equal to 65 degrees. That leaves me with angle V as the unknown. So this guy right here is my X. See, I didn't even have to do math like on the last one, and I already figured out what angle U is. So now I'm going to go ahead and find out what angle V is. So our unknown is the measure of angle V. Our equation is add all of these guys up, so angle T plus angle U plus angle V plus angle W is equal to what? Well, what type of shape is this? It's a quadrilateral. So that means it's like this guy over here. And again, we had said that any quadrilateral is 360 degrees. Well, this kite is 360 degrees. So we're going to go ahead and substitute and solve, and we'll see in a little bit. And you should get that the measure of angle V is 139 degrees. Boom, done. You should be able to solve for any type of angle. We will do line segments or the sides and diagonals later. But for now, we can solve for angles.